I'm Vashni from the Department of Computer Application. Today I'll be presenting my project titled Cloud Disaster Recovery and Business Continuity. These are the contents of my presentation: company profile, abstract, system study, database design, modules, application flow, screenshots, project design, testing cases. This is my company profile. Ramisis Technology. It's a software and IT services company founded in Kolpati at 2023 with a solid foundation in many services. They are well equipped to specific needs of the business operating in healthcare, food, travel, tourism, e-commerce, banking, technology, manufacturing, and IT enabled education service industries. This is the abstract. This project aims to design and implement robust disaster recovery and business continuity plan for a three-tier web application deployed in a cloud environment. The project focuses on ensuring minimal downtime and data loss in the event of a disaster while also addressing business continuity requirements. The purpose of this architecture is to ensure scalability, high availability, and security for the application hosted on AWS. The goal is to ensure minimal downtime and data loss in case of an unforeseen events like infrastructure failures, natural disaster, or cyber attacks. This is my tech stack requirements. For the front end, I'm using HTML, CSS, JavaScript. For the back end, I'm using Node.js. For the database, I'm using MySQL. For the cloud platform, I'm using AWS. System study. This is application architecture. In this application architecture, it consists of three tiers: web, application, database. For the presentation layer, it will host the static files like HTML, CSS, and JavaScript. For the application layer, it will handle the logic and it will process the request. For the database layer, it will store the application data. This is the system flow. The user will open the browser and then we will type the domain name. Then it will route to the DNS resolution. Then it will point to the ALB, that is application load balancer. Then according to the request, it will point to the EC2 instance, that is the front end login page. Then after the correct credentials, it will route to the backend, that is the dashboard. Then we can see the dashboard, that is the charts. It's an interactive graphs. Then if you want to log out, we can log out. Warm standby. This is the method I'm using in this project. It is an active passive region. In the primary region, it will operate in full scale. In the secondary region, it will be scaled down version of the infrastructure is always running. In this, the traffic is redirected to the secondary region using the Route 53. The standby infrastructure scales up automatically to handle the production workloads. For the continuous replication, the data consistency between the two regions is ensured. Recovery objective definitions. RTO and RPO are used. For the RTO, it is the maximum acceptable downtime for the application. For the RPO, it will represent the maximum acceptable data loss. These are the modules I have used in the project: user interface module, application logic module, management module, backup and recovery module, disaster recovery module, monitoring and alerting module, security and access control module, DNS and traffic routing module. User interface module. In the user interface module, it is responsible for how user interacts with the web application. It is built using HTML, CSS, and JavaScript to create a responsive and user-friendly front end. This module handles the layout, form inputs, and dynamic content the user sees in their browser. It plays a crucial role in ensuring a smooth and intuitive user experience by communicating with the backend server to fetch the data in real time. Application logic module. In this module, it will handle the core functionality of the system using Node.js as a server-side runtime. It processes user requests, executes business logic, manages sessions, and handles data passed between the frontend and the database. The NGINX server is used alongside Node.js as a reverse proxy to direct traffic, manage load balancing, and handle SSL termination. Together, they ensure the application runs efficiently, remains scalable, and can handle multiple simultaneous users. NGINX server is nothing but a piece of software. Database management module. In the database management module, it uses the MySQL hosted on the RDS to store and organize all structured data used by an application. It will include the user profile, application setting, transactions, and logs. The tables are designed with proper normalization and indexing to improve the query performance and data integrity. With multi-AZ deployment, this module ensures high availability and automatic failover, which is essential for the disaster recovery and data consistency. Backup and recovery model. This model focuses on protecting data from loss or corruption by implementing regular backups and providing options for quick restoration. Using AWS Backup and Amazon S3, data is backed up automatically at scheduled intervals. These backups can be restored in case of system failure, accidental deletion, or disaster scenarios. This model plays a crucial role in meeting the project recovery time objective and recovery point objective. Disaster recovery model. In this model, the application can continue operating or quickly recover during unexpected events like outages or cyber attacks. It incorporates several AWS based DR strategies such as backup and restore, warm standby. It uses EC2 AMI autoscaling groups and Route 53 for the quick failover and infrastructure readiness. This model is essential for maintaining business continuity with the minimal downtime. Monitoring and alerting model. To ensure the application runs smoothly, the monitoring and alerting model uses Amazon CloudWatch to track the performance metrics, application logs, and system health. It can generate alerts for anomalies such as high CPU usage or failed backups and notify administrators through email or SMS using the SNS. This module allows proactive maintenance and quick response to potential issues. Security and access control module. The security, the AWS IAM, VPC, and security groups are used. For the IAM, it will control who can access the resource and what actions they can perform. VPC will isolate the resources within the secure network boundaries, and security groups act as a virtual firewalls to control the traffic in and out of the EC2 instance. This module ensures the application is protected against the unauthorized access and threats. DNS and traffic module. This module uses the Route 53 to manage the domain name services and direct user traffic to the appropriate resources. It will support the health check, DNS failover, routing policies, which help keep the application highly available. During a failure in one region or a server, Route 53 can quickly redirect traffic to a healthy standby system, ensuring uninterrupted access for the users. SAS. This is the dashboard for the Plasma AI. It will track the user growth. In that, we can see the number of active users is growing over time. For the monitor server performance, it will track the metrics like CPU, memory usage, app crashes, or server load. For the analyze feature adoption, it will understand which features of the platform are being used the most. For the track revenue, it will view the revenue breakdown by different segments like subscription types, regions, or payment methods. Make data driven decisions. Use the insights to improve your system performance, target new features, or adjust pricing models. This is the application flow. The user will open the browser, it will redirect to the DNS resolution, it will point to the application load balancer, it will handle the HTTP and HTTPS request. The HTTP will directly redirect to HTTPS using the ACM certificate. Then it will go to the front end EC2 instance. Then it will go to the back end EC2 instance. The front end is nothing but the HTML dashboard, and the back end EC2 is MySQL. MySQL, it will store the information, application data, usage log, metrics. It will send data back to the backend and the backend responds to the front end. Then the user can view the dashboard using the chart.js. Then we can log out. These are the services used in the project: domain name resolution, application load balancer, front end EC2 instance, back end EC2 instance, Amazon RDS, Amazon Certificate Manager. For the networking and security, the security groups will act like a virtual firewalls. It will allow to access the front end, back end, and the back end will access the RDS. And the network ACL will act as at the subnet level for the traffic filtering. You have configured it to allow all the necessary traffic. For the VPC and subnet, it will keep our resources isolated and secure. Your ALB is in public subnet. EC2 and RDS are in public or private subnet depending on the use. This is the admin login page. This is the admin dashboard. This is the backup and recovery configurations. This is the health check for the application. If the application is running smoothly and there is no disaster or anything, the status will be healthy. If there is anything not well, it will change the status to the unhealthy. This is the CloudWatch alarms. This is the policy and schedule details. This is the DNS record sets. This is the project design. It is a secure, scalable platform where the user can log in. It can access the AI-based business analytics. It will admin, monitor usage, performance, feature adoption, revenue, etc. For the infrastructure as a design, the Route 53 will handle the request and it will point to the application load balancer. It will handle both the HTTP and HTTPS with the ACM certification. Then it will go to the EC2, that is the login page. Then if the credentials is correct, it will go to the backend EC2, that is the admin dashboard. Then it will point to the MySQL and it will show the interactive graphs. This is the testing cases of the authentication and authorization, user growth, server performance, revenue tracking, disaster recovery testing, load balance and failover, cloud infrastructure. For this testing cases, I used the Postman. This is the outcome of the project. I have published a paper in international conference on computer science and engineering. Thank you.